Hello, in this video, we want to look at question in gradient vector. Now, what do we mean by gradient vector? Let's define gradient vector. Let phi of x, y, z be a scalar function. Let phi of x, y, z be a scalar function. The vector defined by the grad, that grad is denoted by this symbol, of phi is defined as, how do we define, what's the mathematical definition for the grad of phi? Grad phi is equal to I divide the x, that is partial derivative of phi with respect to x, plus g divide the y, plus k divide the z. So this is the mathematical formula for grad of phi. It is usually defined on scalar function. So let's look at an example to buttress this illustration. Let's solve a problem. Let's solve a problem to solve this. Let's solve this problem. Example. You can call this example 1. Find the grad of phi if 1, phi is equal to ln the modulus of r, ln of the modulus of r. 2, phi is equal to 1 over modulus of r. Now, let's look at this. Now, how do we solve this? Okay. First of all, we are made to know that phi is what? Is a scalar function from our definition, and grad is a vector function of phi. So what does r stands for? R itself can be written, that is the component of vector r is written as xi plus yj plus zk. This is the component of vector r. Now, what is the meaning of this symbol? This symbol means the modulus of r. So let's express that. The modulus of r is expressed as x squared plus y squared, that is the square root of x squared plus y squared plus z squared. So this can be written another way as x squared plus y squared plus z squared, raised to power half. That's another way of writing this, according to the law of indices. So this is the modulus of r. So now, ln modulus of r. Ln modulus of r will simply be ln x squared plus y squared plus z squared raised by half, which could also be written as, according to the law of logarithm, and write it as what? Half ln x squared plus y squared plus z squared. Okay, that is another way of writing it if you want to rewrite it. Now, but the question says we have to find the grad of phi. So we have expressed our phi now in terms of the modulus of r. Beautiful. Now, how do we now find the grad of phi? That is not difficult. Let's use our formula. So recall that. Let's write it again. Recall. Grad of phi is equal to I divide, that is partial derivative of phi with respect to x, plus j partial derivative of phi with respect to what? Y, plus k partial derivative of phi with respect to z. So in that case, you just do some substitution. So grad of phi will now be Now we have known what phi is. Phi is lane modulus of r. So just say I, d phi of. Now it will be better so that we don't run into trouble. Let's write half. Let's bring half out. Yes, let's bring it out. Or better still, you can say, okay, I have because we want to d dx of lane x squared plus y squared plus z squared. Yes, we bring this half out. I must come out first. Then half, we are supposed to have half lane. So now put half. You can put d of, but it's a constant. You can bring half also out. So we half d of this. Okay. Do the same thing for j. Half. I hope you understand. D dy of lane x squared plus y squared plus z squared. Do the same thing for the last one. It's very straightforward. The last one is what? Plus k half the dz of lane x squared plus y squared plus z squared. Yes. So with that now, it will be easier to evaluate. So what do we mean by this? Beautiful. Now, don't forget that the question is talking about lane modulus of r, and the modulus of r as half. Yes. From that illustration, don't let us make that mistake. But we have brought the half here. No. Yeah, half is no longer there. Sorry about that. Half is no longer there. We have brought it here. We have rewritten it. Now, so the next thing now is you can factor out the half. Half can be brought out so that we have I. Yes, half is common. I for this one. Okay. Now, we want to differentiate with respect to x. So this will be 2x. Then this is like function of function. Now, differentiate with respect to x, 2x. Now, what do you have left here? You have everything here is raised to power 1. Are we together? Are you sure? Good. So, now, and since it is lane something, in lane, when you are differentiating lane, whatever you have here, when you have differentiated partially with respect to that thing, the result will be 1 over everything here. So 1 all over x squared plus y squared plus z squared. I will show you with an illustration. If you can get it right here, if you differentiate lane, let's say y is equals to lane x. You first of all differentiate x. So dy dx now will be 1. Now multiply it by the reciprocal of that x, 1 over x. So that will be everything but 1 over x. So if you differentiate lane x, get 1 over x. So here also, now this is partial derivative. Now what we mean by here, first of all bring out, because half is common to all of them, I is not common, so half I. Now you want to differentiate partially with respect to x according to this statement. So you now differentiate the one that has x, that's 2x, good, multiply by 1 over the reciprocal of everything, because you are now differentiating lane. So that's the method. After you have differentiated with respect to x, which is 2x, now one reciprocal of every other thing, you multiply by it. That is that. About that. Now plus, remember our half is common. Okay. Now j d dy, partial derivative of d with respect to y. So it's what? Times 2y. It is lane 1 all over everything there. X squared plus y squared plus z squared. Beautiful. Now plus k. Partial derivative of don't forget half is common, yeah. Partial derivative of this function with respect to z now, that would be what? 2z 2z multiplied by what? 1 all over x squared plus y squared plus z squared. So you can now close the bracket. Let me write the z clearly. You can close the bracket. You can close the bracket. How now? What do we do? All right, don't get it wrong. Just take your time. Half is common now. Okay. Now we can expand the half. Beautiful. You can expand the half. 2 times 2x here. That will be what? I x all over x squared plus y squared plus z squared. Beautiful. Plus, you know you are multiplying by half. So half will multiply everything. Half times 2y. That is j y all over x squared plus y squared plus z squared. Then plus, you are expanding by 2 sides, k z all over x squared plus y squared plus z squared. Hope that is clear. Oh, it is not clear. Let me write it. Okay, let me write it here. It's very straightforward. Let me write everything here. Okay, yeah. Use half to expand everything. You are using half to multiply half. Oh yeah. You are using half to multiply what? To multiply half. Half times this, we have I x all over everything in bracket. I mean everything as the denominator there. Plus j half times 2y. Y 1 over x squared plus y squared plus z squared. Beautiful. Plus k half times 2z. Z all over x squared plus y squared plus z squared. Beautiful. I hope that is clear now. Fine. Okay. So the next thing now is to expand directly. So we have xi all over x squared plus y squared plus z squared. It will be proper to write xi, not ix. Plus yz all over x squared plus y squared plus z squared plus zk all over x squared plus y squared plus z squared. Okay, now you can sum up everything since the denominator is what? Is the same. So you can add everything together. The denominator is common. Our denominator is what? X squared plus y squared plus z squared. So everything, x squared plus this is 1 times si plus this is called this yz plus this will cancel this zk. Now this one, if you look at it critically, this particular thing is our r. Yes, our r component, the component of our vector. And now remember that this one, we said when we are dealing with modulus of r, we arrive at what? X squared plus y squared plus z squared raised per half. Do you get it now? Do you understand? Now, how do we now get this from this? Now, if we multiply this by 2, we are going to get this. So that means multiplying the modulus of r by 2 will give us this. If you multiply it by 2. Let me write what I'm saying here clearly. Let me write what I'm saying here. Now, I will claim it here. We said modulus of r is x squared plus y squared plus z squared. We obtained that before, raised per half. Abi, recall that. Now, if you multiply the whole, because this is an exponent, if you multiply it by 2 will cancel 2. So we have this left. So that means if you multiply this modulus of r by 2, it will give us this. What is there? Yes. So that means we got what? This one, modulus of r squared. That's how to get this. Modulus of r squared. That is this. That is that about that. So I believe this is understood. Okay, let's look at another question for more clarification. It's very simple. Very simple. Just take your time and go through the way I have solved it. I've solved it. So let's look at another one. The second question says we find phi is equal to 1 over modulus of r. Yes, phi is equals to. Now, without wasting our time, we have already obtained, recall, modulus of r was x squared plus y squared plus z squared. Okay, raised by half. That is what we got for modulus of r. So 1 over modulus of r now will be what? X squared plus y squared plus z squared raised by what? Minus half, because it's 1 over of this is minus half. That's negative 1 over. All right, good. Now, since what? Since grad phi is equal to what? I the phi the x plus j the phi the y plus k the phi the z. Therefore, the grad of 1 all over, 1 all over what? You can put in brackets. Modulus of r will now be what? I d, we are finding this is now with respect to x of x squared plus y squared plus z squared is by minus half plus j d the y, the partial d with respect to y of I squared x squared plus y squared plus z squared is by minus half plus d the partial derivative of d with respect to z of what? Sorry, plus k. So over x squared plus y squared plus z squared raised by minus half. Now, just take it one after the other. It's very simple. Take it one after the other. Oh yeah, let's go there. Let's go there. which implies I. Don't forget we are differentiating with respect to x partially. 2x. Now, if you differentiate the whole of this, this is function of function. I hope you remember. We have differentiated this now. It remains the whole of this. And mind you, don't let us get it wrong. Let's bring out minus half first. And minus half I, because we bring out this. Now, differentiating with respect to x, that will be 2x, good. Now, the whole of this now minus 1. X squared plus y squared plus z squared raised by minus 3 over 2. That is, if you subtract 1 from half, that's minus 3 over 2. Do you understand what I did there? Okay. This is the concept we use in function of function in 100 level. Now, having done that, plus, okay, we are done with x, plus. Now, bring your half out, minus half, now j, okay, differentiate with respect to y. Now you have 2y, then multiply the whole of this. Now take 1 from it, x squared plus y squared plus z squared raised by minus 3 over 2 by the time you deduct half from it. Then plus the last one here, this one, k, we bring half out, minus half, then k, fine, sorry, then 2z now, because we are differentiating z squared, 2z into everything. Now you subtract 1 from the top, x squared plus y squared plus z squared minus 3 over 2. Good. Now let's quickly evaluate that. So we now have, by the time I open up this, 2 we cancel this, we have minus xi. Yes, 2 we cancel this. X squared plus y squared plus z squared minus raised by minus 3 over 2. This one is minus, plus as minus is minus. Zy is jy, x squared plus y squared plus z squared raised by minus 3 over 2. Then plus as minus minus, 2 cancel this, kz x squared plus y squared plus z squared is power minus 3 over 2. Okay, now with this, you can have, by writing this properly, we have xi now, all over, the whole of this will be all over x squared plus y squared plus z squared raised power 3 over 2. If it comes down, yes, if negative, it's like 1 over the whole of this raised power 3 over 2. According to the law of indices, this is minus, don't make mistake here, minus xi minus yg all over x squared plus y squared plus z squared raised power 3 over 2 again, then minus zk all over x squared plus y squared plus z squared raised power 3 over 2. When it comes down, it becomes plus. Okay, now final. Let's look at it. You can have it as minus is common, minus xi plus yj plus zk, everything all over x squared plus y squared plus z squared raised power 3 over 2. So you can write this as, now this is minus r, because the whole of this is component of r, all over. Now this one, remember that we have modulus of r is equals to x squared plus y squared plus z squared raised power half. Now what you can look, if you look at this is 3 over 2. If we multiply this by 3, we multiply our half by 3. Let me write it clearly. Modulus of r, recall, is what? X squared plus y squared plus z squared raised by what? Half. That's the modulus of r. Now, what do we do to this one to get 3 over 2? Just multiply it by 3. If you multiply this thing by 3, that is 3 over 1 divided by 2. That would be what? 3 over 2. You give us 3 over 2. So you multiply modulus of r by 3, you get 3 over 2. So that means the expression here now, this denominator is now what? It's now modulus of r raised power 3. Don't divide. You can't divide r by modulus of r. That would be wrong. So the answer to that is what? Minus r all over modulus of r raised power 3. So on this note, we have come to the end of this problem. If you are watching this channel for the first time, don't hesitate, to subscribe and click the notification bell, so that each time I upload a video, you'll be duly notified. And if you enjoy this video, give it a thumb up, like it, comment, and share it. God bless you.